So in this final video, we'll be looking at the last problem from the practice exam. We have a piston that's being driven down, and what's happening is this connected rod from AB, when the piston is driven down, is going to exert a force on the crank BC, and we're actually told the magnitude of that force that this connecting rod exerts on that crank BC. And what we want to do is determine the moment of that force about point C. So remember, in order to compute the moment of a force about a point, all that we need to do is have an expression for that force in rectangular coordinates, and then have a position vector from the point about which we want to compute the moment, C, to any point along the line of action of that force. So if this force is directed along the center line of the actual crank AB, the first thing that we need to do is define a unit vector along the direction of that crank AB, because we already know the magnitude of the force. So easiest way to do this is note that to go to A, from A to B, if you set this kind of as your origin, that that displacement is going to be negative 42 millimeters in X and then negative 144 millimeters in Y. So that's how I'm getting this RAB for a position vector. If I scale that by its magnitude, that is going to give me an expression for the actual direction of that force. So we were told that the magnitude of the force is 3.4 kilonewtons. If we multiply that by that unit vector along AB, that will give us a rectangular expression for an expression for the force in rectangular components of that force. And then once we have that, all that we need to do if we want to find the moment of that force about point C is just write an expression for the position vector from C to B, because remember, point B is along the line of action of that force. Notice that to go from C to B, you go minus 42 millimeters in X, and then you go up 56 millimeters in Y. So it's just going to be minus 42 comma 56. And then you're going to take that cross product with the result that you got above. And of course, since this is a coplanar force system, you will find that your cross product only has a k-hat component, meaning that all the rotation is going to be about an axis coming out of the plane, either in the counterclockwise direction or clockwise direction. So hopefully that gives you a good idea of what to expect on the exam, and best of luck.